All right, the last thing we're going to cover this semester are carbohydrates, and we're going to cover them very quickly. I will tell you now that on the last exam, the last unit exam before the final exam, we will not be covering carbohydrates. I'm covering this because, truthfully, I have no idea what will be on the organic final exam. It is written by the American Chemical Society. Sometimes they put in carbohydrate stuff, sometimes they do not. The last couple of chapters in the book, you never know what's going to be covered. The only thing you know for sure is we don't have time to do all of them. So we're going to look at briefly here, we're going to look at some carbohydrates, just so you've seen this before, so you can kind of know the gist of them. But again, they will not be covered on the last unit exam. All right. So first of all, carbohydrates are usually sugars and starches. They are polyhydroxyaldehydes and ketones, or compounds that can be hydrolyzed to them. So we shall look at some examples of carbohydrates. For example, glucose is a carbohydrate. Cellulose, a main component of wood, check it out, is a bunch of glucose molecules all bonded together. As is starch. Starch is also a bunch of glucose molecules bonded together in a different arrangement. All right. Now, the thing about carbohydrates, while they are polyhydroxyaldehydes and ketones, a lot of them, I would say the majority of them, what you find is every carbon in the molecule is bonded to an oxygen. So for example, if we look at this piece right here, this carbon here is bonded to this oxygen, next carbon is bonded to that oxygen, next carbon over bonded to this one, this is bonded to this one and that one, this carbon's bonded to that oxygen, this carbon is CH2 bonded to that oxygen. It is very common to see a carbohydrate with every carbon bonded to an oxygen. Okay. So when you have these saccharides, when you have monosaccharides that we'll be dealing with, means we don't have them all bonded together, they tend to be divided into aldose and ketose. An aldose means the end carbon is an aldehyde. A ketose means we have a CH2O and then a ketone group. So note next door we have glucose here. Glucose has an aldehyde at the end, so it is an aldose. This is fructose, the sugar fructose. It is a ketose because it has a ketone group there. If it's tough to see in this video, if it's not totally clear, which I imagine it won't be, this is in your book or it's in any organic textbook on their carbohydrates chapter. All right, so let's skip a bunch of stuff now that we know that. Note that many of these monosaccharides can have multiple stereo centers here. If we look at this guy right here, if we have 1, 2, 3, 4, 5, 6 carbons in this guy, note in this Fisher projection of it, we have 1, 2, 3, 4 chiral carbons. So we can have many stereoisomers of these sugars. All right. So let's keep going because I'm not worried about this. Note they have your family. Note here's the family of D-ketoses here. And I'm not worried about knowing the DNL. You may want to look at that because it's, frankly, the DNL for sugars will confuse you because the D and L with saccharides take the place of R and S, which is confusing because when you think of D and L, you think of dextrorotatory and levorotatory. The D and the L of D-allose, D-glucose has nothing to do with the optical rotation of the molecule. Yeah, it is the D anomer because of the OHs on the right side and not the left side. That's what makes it the D. It has nothing to do with optical rotation. So just so you know that. But again, I'm not going to have you do any problems like that. I don't know what ACS is going to do. The other thing to realize is that oftentimes these monosaccharides form rings. If you looked at the glucose that we saw at the very beginning, it was a ring structure. That is known as a Hayward projection, and a lot of times the glucose are in these ring structures. And if we look closely at this, if we see here is the acyclic, the normal acyclic D-glucose, which is an aldose because of this aldehyde, what will happen is this OH attacks that carbonyl to make this ring. All right. And it'll do it two ways, the alpha anomer with the OH down here, the beta with the OH up. But note what we have here. We have a carbon with an OH on it and a carbon bonded to an oxygen bonded to another R group. So this is ROCOH. And what is that? That is a hemiacetal. So these Hayward projections of these molecules show these sugars as cyclic hemiacetals. Which means they can probably do a lot of the reactions that hemiacetals can do. Okay. And truthfully, there's only one last thing that I'm worried about. Now, this chapter is big. There's a whole lot of things you can do with these saccharides. You know, we got glycosides here. We've got naturally occurring ones, reactions, oxidations, reaction at the carbonyl group, all sorts of interesting stuff to some people, not so much to me. Yeah. Oh, there's lactose. Yeah, lactose. I hate lactose, you know. Yeah, I'm lactose intolerant. So the last thing, though, that we're going to worry about is good old DNA versus RNA. You might have heard that DNA is deoxyribonucleic acid, RNA is ribonucleic acid. And so when we look at those, what we find is, if you know about DNA and RNA, these nucleic acid, they're phosphate, sugar, and base make up this nucleoside here. And when we look at the sugar for ribonucleic acid, we've got this ribose ring here. We've got this oxygen. Here's this carbon bonded to this CH2O here. We've got this one here. This is a ribose. This is RNA. For DNA, note this OH is missing. There's no OH there. Note the hydrogen is here because there has to have 4 bonds, so there's a hydrogen here. So what is missing between this and this? The oxygen. So this is the deoxyribose. So this is deoxyribonucleic acid because each one of these riboses isn't a real ribose. It's missing that OH there. So this is deoxyribonucleic acid. This is RNA ribonucleic acid because each one of these is the ribose. It has that OH there. Cool. As I said, this chapter goes on, and there's a whole lot of useful information for people who are really jazzed about carbohydrates. I am not. I really try to limit my carbs, so that's where we're going to end this semester.